Hi, my name is Elke Jacobs and I'd like to show you my latest project, UberFridge. UberFridge is a fermentation temperature controller that I've built for my old fridge. I'm running a test now with a bucket of water, but normally of course I ferment beers in this bucket. UberFridge has two sensors, one in the beer and one for the fridge temperature. And both sensors are connected to an Arduino Nano, which is inside this black box. The Arduino runs a temperature control algorithm which can regulate the beer temperature to a tenth of a degree and the fridge temperature to a half degree accuracy. The Arduino switches two relays, one for the compressor and one to turn on the light in the fridge, because when I have to raise the temperature I just turn on the light and that's enough to increase the temperature to 30 degrees. I've got an Oled Display to display the temperatures and settings, and I've got three buttons here for a menu, so I can select the mode of operation and temperature settings. But I probably won't use that much because this fridge also has Wi-Fi. There's an open source router inside which does data logging and runs a web interface. So if you come with me to my computer, I can show you the web interface.
So this is the UberFridge web interface. It is provided by the router, which runs on DDWRT and Optware. The router also runs a Python script, and this Python script communicates with the Arduino over the serial port, and it communicates with the web server over an AF Unix socket. In the middle you can see the temperatures and the temperature settings in a Google annotated timeline graph. I use the annotations for when the settings change or when the fridge door is opened. The control panel at the bottom is used to change the settings. Right now it's running in beer profile mode, and this means that the beer temperature setting is following the profile you see in its graph. You can change this profile with the Edit Profile button. This opens a Google spreadsheet which is used to set the profile. You can set the start date and you can set after how many days the temperature should be which value. If you save this and close it, then with the upload profile you can send this profile to the router and the Python script will start following that profile. I can also set the fridge to a constant beer temperature on this tab or a constant fridge temperature on this tab. I can change the setting with these buttons, and when I hit apply, the settings are sent to the Arduino. When the fridge is running in beer profile or beer constant mode, the fridge setting is automatically adjusted with a PID algorithm to get the beer temperature to the right value. So that's the control panel. On the top you see a live version of the Oled display. This is updated every 10 seconds and is exactly what's on the fridge. And on the right you have a button that shows the script status. I can use this button now to stop the script, and when the script is not running I can use it to start the script. Finally, there's the maintenance panel. Here I can change the settings, I can change the interval between data points, and I can start a new beer. On the second tab I can display the output of the Python script. On the third tab you can see previous beers. So I can select a beer, hit show, and it will show you the graph of that beer. I can also download a CSV file of this beer. And finally, I can reprogram the Arduino from the web interface so I don't have to open my fridge when I want to change something in the Arduino program. So that's it. That's the UberFridge web interface. If you're not into brewing beer, it still works in that loop because I basically wrote a framework to communicate with the Arduino from JavaScript. So you could also use it to control robots, control mood lights, control any electronics that you want to control from a web interface. Thanks for watching.